This video covers Stat 454, Chapter 7, Section 2, Part 2, the minimal cost method for determining basic feasible solutions to transportation problems. Previously, when creating a basic feasible solution to a transportation problem, we just filled in the table as it became available, starting with the northwest corner and moving on to the southeast corner. That process doesn't take into account any of the costs associated to any of the variables. So this time we are going to fill in the table starting from the least cost and moving up to the most cost. If there's ever a tie, you can break the tie arbitrarily. Also, don't forget, if you ever come to a place where one of the columns needs to be 0, actually write down the number 0. So take a look at this table. The costs are in the small corners inside each main box. I'm going to start at the smallest and work my way on up. Be careful, it is very easy to accidentally miss one of these boxes. So the smallest box I see is row 2, column 2. Its cost is 1. So I'm going to pick the smallest number out of 8 and 10. That value is 8. That X's out 8 and reduces 10 by 8 to yield 2. The first pass through. Now, I'm going to look for any other instances of 1 on this table, and I don't see any. So 1 is complete. Move on to the next largest number, 2. I see 2 appearances of 2 in row 1, column 1, and row 2, column 1. I can break ties arbitrarily, so I am going to pick the 1-1 entry. The most I can do in 1-1 is the least out of 5 and 12. I believe that's 5. That X's out this quantity and reduces 12 by 5 to give 7. A lot of students at this point will try to go to the next number after 2, which is 3, but you still have another 2. So I'm going to go to the next 2. And in this one, it needs to be the most out of, the least out of 2 and 7. So that's 2. Xing out this and making this number 5. I'm going to check for any more 2s. No more 2s. Next, I'm going to check for 3s. I see there are 3 of them in 3-1, 1-2, and 2-3. How about I'm going to be arbitrary right here. I'm going to pick this one in 3-1 just so I can fill out that column and make this row 10. Any more 3s? Oh, I actually can't do this 3 because it's already in a blanked out row and column. Oh, and I can't do this 3 either because it's actually in a blanked out row. So it looks like those other 3s I wasn't free to choose at all. I had to choose the one in 3-1. So let's see, next number past 3 is 4. There's only 1 entry for 4 in row 2, column 3. The most I can put here is 4. That X's this out and turns this into a 6. And now, if you take a look, there is only one other cell that admits any values. It's this corner right here, which X's those 2 values out. So be careful as you fill in entries in the minimal cost method. Don't skip values. People tend to do that. And don't accidentally put a value in a row or column that is already X'd out. So how do I read this basic feasible solution? Well, I have non-basic variables of x12, x13, and x14, x23 and x24, and x32. All of these quantities equal to 0. and I have basic variables that come out as a result of these choices of x11 equal 5, x21 equal 2, 2 equal 8, 1 equal 5, 3 equal 4, and 4 equal 6. Those are the basic variables and non-basic variables, the initial basic feasible solution that comes about as a result of performing this minimal cost method. This is all of the content related to Chapter 7, Section 8, Part 2, the minimal cost method of finding basic feasible solutions.